All right, let's do one example related to Kolmogorov-01 law. And let's look at the random walk, because that's maybe something that we have already seen in some other courses, for example, the stochastic processes course. And in stochastic processes, we looked at, for example, a random walk where the location at time t is the sum from where s goes from 1 to t, and we sum with xs, and we assume now that xn, these xs are plus minus 1. So you could think of gambling, either you win €1 or you lose €1. Let's say you lose €1 with probability 1 minus theta, and you win with probability theta. Okay, so theta is some parameter that we fix. So that's some parameter between 0 and 1 that describes our model for the random walk. And let's see, assume that these outcomes of the game, if you think about gambling, so let's assume that x1, x2, etc. So these outcomes of our gambling are mutually independent. Natural thing to assume. So with this assumption, this is our wealth after t rounds of playing a game where we might win or lose €1. So our net profit. We could think about this random walk as a net profit after playing t rounds of this type of game where the probability of winning is theta. Right. So if you are, let's say, kind of a long-term investor, you might ask, okay, could you make money? So we could ask about this event. What would happen in the really long run if you would never stop gambling? And you would ask, okay, would you make eventually an infinite profit? Okay. So this would be kind of the buy and hold problem somehow. Yeah. Would it be? Would it give you infinite profit in the long run if you remain in the game forever? Well, intuitively, if you look at the supremum, so will you eventually get infinite amount of money? So the game this is a random walk. You start at 0, you go up, you go down, you go up, down, and so on. So you get the zigzagging random walk. That's how your random walk will look like. And this is your time t here, which goes from 0, 1, etc. up to infinity. So for this random walk, does it approach infinite? Or that's the question, and this event A is there to answer this question, or to model this question, let's say so. So if you omit some initial part of this sequence, so then it doesn't affect the supremum. So that's why your homework here might be that you should check that A belongs to the tail sigma algebra. This is a tail event with respect to these random variables x1 up to infinity. So now Kolmogorov-01 theorem tells us that the probability of A is 0 or the probability of A is 1. That's what Kolmogorov tells us for the random walk. So either you get, in the long run, you get infinite profit or you don't get. But Kolmogorov tells that there's no randomness in this question. Either this happens surely or it surely does not happen. And we can apply this when we assume that these random variables x1, x2, etc. are independent. This is true for any theta. And so this is why Kolmogorov's theorem is so fundamental. It tells about this type of things. It also could be used to tell about epidemic models. So if you look at the epidemic with some branching process type of thing, so will the epidemic die out eventually or will it survive forever? These may be 0-1 law type of questions, which either happen with probability 1 or probability 0. So in the long run, kind of in this type of things, there's no coin flipping or no randomness anymore. Then the question, of course, is that, okay, which one of these happens? that's where Kolmogorov cannot help this theorem. Of course, Kolmogorov's other theorems can help, but the 0-1 law does not tell which one of these two options happen. For that, we need more detailed work. Remember, for this fact, the only assumption was the independence. That theorem does not look about the sum structure or anything about this, any details of the model, only about independence. Independence implies that in the tail, we get 0 or 1 probabilities. So if you want to know which one of these happens, so you need more detailed analysis. Maybe we have time to do that in this course, but what is the answer? Well, if theta is less than 1/2, this probability is 0. If theta is bigger than 1/2, when you are more likely to win, this is 1. When theta is equal to 1/2, what happens? When theta is equal to 1/2, you get 1 also.